Give the product or products that you would expect to be formed in each of the following reactions. The first one, this with methoxide. Now, here the product or products can be SN1, SN2, E1, or E2. Now, coming to this question, methoxide is what we are using here. Now, coming to the substrate, this substrate is a 1-degree alkyl halide, right? Coming to this, it is a strong base, of course, a very good nucleophile. Moreover, it is unhindered, right? So here, because it is unhindered and a very good nucleophile, we can expect SN2 product as the major product. Like the product here can be this. Major product is by SN2, right? So the product is going to be this. Minor product is of course by E2, which actually gives this product. See, in case of this, why can't the E2 product be major? No, it cannot be. Because I hope you remember that in case of both E1 and E2, the order of reactivity follows 3 degrees greater than 2 degrees greater than 1 degree. Isn't it? A 3-degree halide can give E2 better. Of course, even E1 also. But reasons are different. We have already seen them. In case of E1, because it is via a more stable carbocation, 3 degrees favorable, more favorable. In case of E2, if it is 3 degree, we get a more substituted alkene as a product. So reasons are different, but the order of reactivity is the same. So looking at the strong base, We can think of course, SN2 or, I mean, looking at the strong base, we can think of E2. And of course, it is a very good nucleophile. So we can think of SN2. But the major product is by SN2. Only the minor one is by E2. Because in case of E2, reactivity follows the order 3 degree, 2 degree, 1 degree. Okay. And moreover, the most interesting point here is the unhindered nature of the nucleophile. Next. Look at this. See, in this case, the substrate is again a 1 degree halide. So 1 degree halide as such refers to SN2 or E2, right? Think of both, no issue. But now the break. What is this? Tertiary butoxide is, of course, a nucleophile, a base, but a strong base, okay, a weaker nucleophile because it is hindered. So, no doubt SN2 is ruled out, hindered, therefore no SN2. So, the only possibility is, of course, 1 degree can undergo SN2 or E2. But the point is, SN2 is not possible. Therefore, the major product will be by E2 pathway. This is going to be the major product. Because no SN2 is possible, we are going for E2. Of course, even for E2 also 1 degree is not that favorable. But still, because the base what we have used is a hindered one, or the nucleophile what we have used is a hindered one, you cannot go for SN2. You get a minor product. Now this is going to be the minor product. So this is how you have to rule out the possibilities one by one and have to arrive at the final major product. Next, take this. How about this? Now coming to the substrate, see it's a 2 degree alkyl halide, isn't it? Moreover, this is a chiral center. Let us see the configuration. First, then this will get the second rank, this will get the third rank, this will get the fourth rank. Come on. Going from 1 to 3, we are going in an anti-clockwise direction, and no doubt the least priority group is with a dash. So the configuration is S, right? You know, this SH minus is of course a stronger nucleophile. H2S is weaker, but its anion SH minus is stronger. A strong nucleophile, but a weak base. When you go for a 2 degree, you know, you will have all the possibilities. But looking at the stronger, I mean the negative charge, you can just think of SN2 or E2. But because it is a, I mean, it is a weak base. So let me just rule out the possibilities one by one. Looking at the 2 degree, it can of course be SN1, SN2, E1 or E2. Anything, no problem. All are possible. But the point is, when you come to this area, SN2 is okay because it's a stronger nucleophile. You don't need a stronger nucleophile for SN1, and you know, a weaker base. So no E2. That's it, ruled out. So this is how you rule out the possibilities and arrive at the final major product. You know, in this case, I would actually like to give you the SN2 product. And remember, when you go for SN2, it of course will cause inversion, right? At the chiral center. So obviously you will get this kind of a product. Okay. Now this will obviously be something with our configuration. If you want, I'll check. Come on. This is 1, this is 2, this is 3, this is 4. Going from 1 to 3. Again, we are going in anti-clockwise direction, but the least priority group is with wedge. So take opposite. So this is S but R. Okay. Next. How about this? Okay. See, coming to this OH minus. Okay, first the substrate. You know, the substrate is a 3 degree one. So we cannot think of course, SN2 can be E2. Cannot be SN1. Look at the things. 3 degree. So straight away no SN2. And look at the base or the nucleophile, OH minus. You know, it is a stronger nucleophile, of course, a stronger base. SN2 is anyway ruled out. So then we can go for E2, isn't it? Though the nucleophile is stronger because the substrate doesn't allow the nucleophile to approach. It's a hindered substrate, isn't it? Substrate is hindered. So go for the E2 product. The major product will be by E2 path. See, this of course can be given as the product. Put a double bond here. Okay. Now, let me take one more. Again, here the substrate is 3 degree. Is a 3 degree halide, and look at this, it's only a solvent. So this can of course be a 3 degree halide, can actually favor SN1 or E1 or E2. But see, E2 is anyway ruled out. Solvent are a weaker base, so no SN, no E2. It can be SN1 or E1. But because here, see, till now we have seen 50 degrees, but here the temperature is low. A low temperature generally favors substitution rather than elimination. Generally, high temperature favors elimination. So the major product will be by SN1. So you get this as the major product. Right. So this is how you have to rule out the possibilities, taking the substrate, taking the base or nucleophile into consideration. Okay.